So the first example from today is a golf ball is hit off a tee 5.2 meters above the ground. So if this is our tee, that means this is 5.2 meters. Now it's given an initial horizontal velocity of 23 meters per second and an initial vertical velocity of 13 meters per second upwards. So that means this time our little golf ball is launched at an angle, something like this. There's our initial velocity vector. We're given the x component, I'll call it v1x. We're told that is 23 meters per second. And we're given the vertical component for that vector, v1y, and we're told that's 13 meters per second upwards. And so now we can assume that when this ball is launched, it's going to follow a parabolic trajectory and it'll hit the ground somewhere over here. We're asked, when will it land and where does the ball land with respect to the tee? So we're asked to find a few pieces of information. Just like our other projectile motion problems, we've got to establish a coordinate system. Whether or not you want upwards or downwards to be positive is completely up to you. For this one, I'll mix it up and I'll say up is positive and forward, as always, is also positive. Now I'll set up this problem just like we did last class, where the x direction and the y direction are separated. So I'll start by summarizing all the information I have in both of those directions. In the x direction, the only thing I actually know is the initial horizontal component of velocity, which is 23 meters per second. In the y direction, I have a little bit more information. I know that the initial y velocity is 13 meters per second. I know the acceleration due to gravity is still 9.81 meters per second squared down. And I know that the ball is going to land, obviously, at the bottom of our ramp or incline, which is 5.2 meters below where it started. So that means my overall y displacement is negative 5.2 meters. What would I like to find? Well, I'd really like to find delta dx and the time. In the x direction, the only equation I can use to put all that information together is the equation for constant velocity, which looks like this. And I don't yet have enough information to find delta dx and delta t. So I'll have to go back to that one later. In the y direction, I would like to know delta t. That's one of the variables that I want to solve for. So looking at all the variables in the y direction, I can choose one of the kinematics equations to piece all of those together. And the kinematics equation I'm going to choose is this one. It comes up a lot. So in that equation, the only thing I don't know is time. When I substitute in the things that I know, I'm going to find something really annoying. I have to solve a quadratic equation. Yes, that comes up a lot when you're launching something at an angle in projectile motion. That means I'm going to have to rearrange this equation to solve for delta t. And I'm going to have to apply the quadratic equation. So delta t is equal to negative b plus or minus b squared, take away 4ac, all over 2a. Substituting in these values, b is 13, so I'm going to do 13 squared, subtract 4, a is negative 4.905, and c is 5.2. In the denominator, a is negative 4.905. Now I'll start simplifying, and yes, I will keep track of significant figures as I simplify under the square root sign. So 13 squared, 169, with still two significant figures. That's not super clear, that's pointing at the 6. So there's two significant figures there. Subtract, actually this is going to be plus because I'm multiplying two numbers together that are negative. This comes out to be 102.024, and I'm going to round to two significant figures still because of that 5.2. In the denominator, I have 9.81, and that's a negative. If I simplify under the square root brackets, I'm going to end up getting 271.024, and I'm still going to keep the tens place as my least precise decimal place since I'm adding those two numbers together, and that's still over negative 9.81. Now when I simplify, if I take the square root of 271.024, no, I'm not doing this in my head, it is 16.462807, and I'm going to round to the tens place, two significant figures, or the ones place, two significant figures. Now I'm adding 13 and 16, both of them, well, might be negative numbers in one situation, and the ones place is the place that I'm going to round my final number to. So simplifying this out, I get 2 times. The first time is 3.0033 seconds, keeping two significant figures, and negative 0.353 seconds. But of course, this one is inadmissible because we're not dealing with negative time. So now I have one piece of information. I know how long the ball is in the air. Once I know that, I can bring it all the way up to this equation again and use it to solve for the x displacement. So I can take x displacement is equal to the x component of my initial velocity, which is constant, 23 meters per second, times the time, which I just found out was 3.0033 seconds, rounding to two significant figures. And this gives me an overall displacement, rounding to two significant figures, of 69 meters. So in my final statement, I'll say, therefore, the ball is in the air for 3 seconds and lands 69 meters forward of the tee, since it's a golf ball.